So the next several videos are on triple integrals, and the most obvious use of it is for volume, because back when we did double integrals, when you integrated one dx dy or one r d theta, you got the area of a region in the plane. So same thing with triple integrals. If you integrate one, now it's going to be dx dy dz, or we're going to talk about ways to do it in both cylindrical and spherical coordinates. You're going to get volume. The problem with that is you already knew how to do volume. You actually already knew how to do volume with a single integral. Back in Math 125 or wherever you first learned integrals, remember you did solids of revolution and you had the disk and the shell and the washer method. Those were actually great ways to integrate for volume. And then you did it again with double integrals, and maybe you did some shapes that you couldn't have done before. But there were a lot of volume problems in Math 126 or your previous double integral course. So you can do volume with triple integrals. It's not always better. So I'll show you an example where we calculate volume of a sphere, all the different ways, and then you can see what is or isn't better as when we go through single, double, and triple integrals. So what is it good for? It's good for all the applications we had before. So it's good for mass, center of mass, moments of inertia, probability distributions, all that stuff. So for example, if you had a sphere of radius 3 with density equal to the distance from the xy plane, so like it gets heavier as you go farther away from the xy plane, and you wanted to find its mass, that you couldn't do easily with a double integral. You would have to do a triple integral. Or if the density increased with its radius, then probably most likely to do that in spherical coordinates, and that would be easy. Okay, so we'll see some formulas, we'll see some examples. I won't do a ton of examples of rectangular triple integration or cylindrical coordinates, because cylindrical coordinates is just like polar, except you're adding a dz. So you've seen that before. I'll do a good number of examples on spherical coordinates because that's new and different.